Good morning, my dear third year student. Myself, MD Hashnur from Civil Engineering Department and your DSS class teacher. DSS class teacher. Hope you and your family will and good in this lockdown condition. So today we discuss our important topic, that is the beam design. So at first go through the notes and see the video. Today we discuss a simply supported beam of effective span is 1.5 meter, carrying a factorial connected load of 360 kilonewton at middle span at the middle span. So my given problem is design a simply supported beam of effective span 1.5 meter, carrying a factorial connected load of 360 Newton at the middle span. So let's go to the solution. The maximum moment occur at the span is given by, that is a maximum m equal to wl by 4. So w is putting, that is the 1.5, 360 is putting, that is the value of w, l and 4. So ultimately we get that the 135 kilonewton per meter, that is the 135 10 to the 6 newton per mm. Okay, unit is change. So we find ZP. ZP required is obtained from the relation. Or what is the ZP? ZP is the, we know that discuss in our classes. ZP is the plastic moment capacity. ZP is the plastic moment capacity. So ZP from this relation, there is a FU ZP gamma m0 equal to m. From this relation we get, that is a ZP equal to 594 into 10 to the 3 mm cube. So we take a section. So the trial section is ISMB, Indian Standard Medium Beam 300, which has ZP is that 5651.3.731 into 10 to the 3 mm cube. So this section, the trial section ISMB 300, which has ZP plastic moment capacity is 651.731 into 10 to the 3 mm cube. So the section property of ISMB 300 are given. That is the H. H means the overall depth is 300 mm. Width of the flange B is 140 mm. Thickness of the flange, that is the TF, those are given 12.4 mm. And depth of the web D, the small d, H minus 2 first bracket TF plus R1. So 300 minus 2 by 12.4 into 14, ultimately we get that value. So HF, the center to center distance from the center to center distance of flange. So 300 minus 12.4 by 2, ultimately get this value. Okay. Thickness of the thickness of web, that is the TW. TW equal to TW equal to 7.5 mm. Hmm. So the IZZ moment of inertia in ZZ section, hmm, that is the 8603 into 10 to the 4 mm m to the power 4. ZE, ZE, what is the ZE? ZE is the elastic, ZE is the elastic section moduli, elastic section moduli. So ZE equal to 573.6 into 10 to the 3 mm 4. Okay. And ZP, that is the 651.73 into 10 to the power 4, 10 to the power 4. So those are the given. So self weight of the beam is 0.4336 kilonewton per meter. So those are the given for of our section ISMB 300, Indian Standard Medium Beam 300. So factored weight, uh, factored weight is the 1.5 into 0.44 kilonewton per meter. Okay, the additional factor moment due to self weight is given 15 into 0.33, this value, and ultimately get this point. So total factored moment, there is a m, 135 plus 0.183, ultimately get. So factored shear force due to self weight, so 1.5 into this value and that value, then we get. So total factored shear force on this section, the shear force section, that is a 360 by 2 plus 0.44, ultimately get this vaccine. So now we find out the section classification. So section classification is found out by these methods, that is the epsilon, is root of 250 by fy. So putting this value, then get 1, and overhang b is 150 by 2, getting this value. So b by tf, so putting the value of tf and b, and this get this value, that is the less than 9.4 epsilon. Then we putting this value, and we get that, that is less than 84 epsilon. So that this beam section classification as plastic section, which is class 1. So our section classification is completed. So we divided this math in two parts. First part up to section classification, and following part is classified in our next class, that is the part 2. Okay, thank you.